Hi, I am Ayush Mittal and today I am going to present a survey conducted on power saving techniques in mobile computing. Introducing this area, looking back at the history, the first mobile phone was developed by IBM in the year 1992, named as IBM Simon. After that, in the year 2007, Apple launched first operating system named as iOS. Followed by it in the year 2008, Android was launched. It was a time when new smartphones started coming in market and the era of smartphones started. These days, smartphones have power-hungry application and features. Due to this, it has become important to study techniques which can save power in these mobile devices. Here in this graph, you can see a market share of different operating system. Number one is Android and then followed by the iOS. Moving forward, I will talk about what areas are being covered by me in this survey and in this presentation. First, various operating systems are studied and will be seen at how they can be improved to save energy. Second, power saving techniques in LCD and OLED are discussed. Third, two well-known techniques DVFS and DCS, which are known as dynamic voltage frequency scaling and dynamic course selection respectively, are discussed. Various power profiling techniques are discussed. It is observed that many researchers have used machine learning algorithm in combination of power profiling techniques. This has resulted in good results. And finally, we will be talking about a little bit about unperceived activities, which are also known as hidden activities. This is a new area of research which is need to be highlighted. Now moving on and talking about the operating system, Android is based on a Linux kernel. Linux has a very efficient power management module for server. But there is a lot of difference between the power source for server and mobile. So the power management module was modified for Android. The power management of Android consists of these wake locks which are shown in the table, and they are responsible to control the other modules like the keyboard, screen and CPU. An interesting study showed that wrong manipulation of these wake locks can lead to no-sleep bugs. So let us understand what are these no-sleep bugs. These are the bugs which keep the CPU active even if the mobile is in standby mode. So developers need to be careful for this manipulation of these wake locks. Similar wrong manipulation of power management module in the iOS and Windows lead to poor power efficiency. Another paper analyzed the power consumption of various modules in a mobile. The author just did the analysis but omitted an important conclusion from the analysis. It was that if the mobile is kept in 2G mode when it is in standby instead of 3G, the energy saving is up to 60%. In another paper analyzed by me, it was on TinyOS and Android. No doubt TinyOS has better power efficiency, but TinyOS cannot be used for smartphone as it does not have as many features as an Android have. So, moving forward, another paper was studied and analyzed, and that was on iOS. And it was concluded that the wrong manipulation of timers in the power management module of iOS may lead an application to be in foreground active state when it is supposed to be in foreground inactive state. So what we understand from is that if a programmer manipulates wrong timers in iOS, then it may lead to not really good results. Now talking about Android again, various power saving techniques like set CPU and juice defender in Android were discussed, which use frequency scaling technique to save power. But one should note that frequency scaling may lead to thermal spikes, which degrades performance and not good for the life of the processor. Finally, talking about the future trends in Android was studied and found that client-server based models to generate power-saving schemes are being developed, which will be discussed in a later section. At the end, it was concluded that Android and Windows have better flexibility to develop for the developers to control the power management module, and iOS developers have very low flexibility on that part. Moving forward and talking about the displays, a study showed that mobile display consumes about 40 to 60% of energy of the whole system. So, energy can be saved using the new Pentile technology, which uses only 8 subpixel to represent 4 pixel, when compared to a traditional RGB strip. In this figure, you can see the structure of pentile versus an RGB strip. So the key idea here is that to represent 4 pixels, you just only need 8 subpixels of pentile, but to represent same 4 pixels you need 12 subpixels in an RGB strip. So from this we can conclude that if we are using a pentile technology, we are saving the energy and even the memory part. And if this pentile is applied to an OLED, which was studied in a paper, it showed that the memory and the source channels are decreased to 2 by 3. So that's a considerable amount of saving. Another paper was read about the Guide display algorithm, which saves power during a real-time video call. Savings were up to 12.5%. Moving forward, market has a new display. Market has a new display which are known as OLED, which stands for Organic Light Emitting Diode. They consumes 40% less power than the LCD. In a paper, dynamic voltage scaling was implemented in the OLED display. Since OLED power consumption depends on the pixel it is showing, this approach changed the more power consuming pixel with low power consuming pixel without being recognized by the human eye using SSIM. SSIM stands for Structural Similarity Index Matrix. However, sharp edges appeared in the images, so the quality of service was hampered again. Another version of OLED is an active matrix organic light emitting diode known as AMOLED. A paper on the power model of AMOLED showed that the old model has 8.848% of error rate, whereas the new model had only 0.59% of error rate. Below here you can see in the presentation that this is a new equation for the representation of the new model. Now moving up to the DVFS and DCS, these are very two traditional approaches. Like DVFS is basically dependent upon the load. If a processor has a less load, the frequency of the processor is lowered down to save the energy. And similarly, in the case of a DCS, what happens actually is if the processor has no load and it's a multi-core processor having 4 processors, any of the 2 or 3 processors will be shut down, and only one processor will be active to save an energy. So here, one of the paper was read in which they used a new Q-learning algorithm and a runtime kernel, which implemented a DVFS scheme. It was a kind of new since it variably predicts the load. And the results of this research showed that after implementing a Q-learning algorithm, the results were better than from the traditional DVFS. Moving on the thermal management part, thermal management is also important. Conventionally, system depends on the DVFS based thermal management, which instead of improving the performance, make it more worse. Now, what is this new approach is all about? In this paper, a new approach and algorithm is implemented, in which the software or the algorithm give you two options. Like the one is the power optimization and the other is performance optimization. The calculation of the final frequency based on the average frequencies of a particular window, like particular past frequencies, and then it gave the new frequency. And it was observed that this new method and algorithm gave you up to 12.7% of more power saving without any performance loss in the case of a power optimization option. And if performance optimization option is selected, and power saving was 6.7% and performance was enhanced by 6.3%. Moving forward and talking about the power profiling techniques, first let us understand what is power profiling. Power profiling means to save the usage pattern and or to save the how a particular user uses its mobile phone, and after saving all those patterns and important information, a power saving scheme is generated either locally or on a remote server. So here, if we are doing it on a remote server and a client server based model comes into picture, and we need to be concerned about the privacy, which were addressed very well in the paper. But the biggest issue of these kind of techniques was that the quality of service was being hampered, like unwanted interrupts while using a mobile phone was coming, if battery is low, then your screen light goes dim automatically. That anyhow hampers the quality of service, which is not recommendable. Moving upon in the power profiling area, another paper used spatiotemporal and device context features. uh, to generate a power saving schemes, and how these power saving schemes were generated were mapped with the help of machine learning algorithms. Various machine learning algorithms like LDA, LLR, MVSOM, and SVM and KNN were used, but the best prediction results were in SVM, which are known as support vector machines. The best part about this paper was that it did not hamper the quality of service. Another paper read was named as it was on a middleware framework known as Aura. It's an interesting technique that is based on the perceptual and cognitive slack of user. And the best part about this technology or this implementation was that it did not hamper any quality of service. Now, moving forward again, we will talk about unperceived activities. What are these activities? These are the activities which generally run when the mobile is in standby mode, like the email synchronization of your mailbox or some notification in your app or updating. They need to be studied in detail. This is an area still where people are working and trying to analyze which important activities can be stopped when the mobile is in standby and which are not. So we need to still work on these areas. Another area is in energy aware computing. An experiment showed that using hardware decoders instead of software decoders for running a video on mobile handset consumes less energy. However, overheads of hardware decoding were not discussed, but still it gave a nice picture and a direction to the developers that how they can develop the softwares for a mobile system which consumes less energy, and they must take care of the overheads like while developing these kinds of softwares. Finally, coming to the conclusions and recommendations, at the software level, proper manipulation of wake clocks in Android will help in conserving energy, and the same manipulation in Windows and iOS will also help. Study for the effective programming technique will surely help. At the hardware level, working on the better pentile structure for AMOLED display can result in more saving of energy. More dynamic DVVFS and DCS can help in effective management of the system. Power profiling and machine learning algorithm when combined can bring a significant change in developing more effective power schemes. And finally, energy over computing and unperceived activities are the area that still need much research to get some fruitful results out of it. Finally, I would like to thank Dr. Sudeep Pasricha for his continuous guidance and advising on his paper. And this is the end of presentation. Thank you for listening.